And everybody else is gonna watch our mother.
Shut up. No. Everybody's recording, guys. Now, we are talking about types of roots of quadratics. And this is one of the most important things you're going to learn. You're going to continue to use this in all the levels of math. If you go and study any engineering, any science, any math, you need to know the types of roots. They indicate certain things that are very important. Now, all of this comes from the quadratic formula. Okay? All of these types of roots we're going to look at today are based on the quadratic formula. Can anybody raise their hand and tell me what the quadratic formula is? Brandon.
Oh. Sure, negative b.
Oops. X equals, right? Good.
Plus or minus square root. B squared plus minus 4ac.
Man, it's Brandon.
Good.
All over 2 times a.
Very good, Brandon. Very good.
I had a dream about this.
Nobody else can
Okay. We gotta remember. We gotta remember, guys. Okay. This formula is extremely important to know. You should never really forget it for the rest of your life. You remember this one thing.
That is not
Sure, Jason. Go ahead.
x equals negative b plus or minus squared.
May I have your attention,
B
please,
squared minus
students
4
and faculty.
all over 2.
That's it. Very good.
It is now 9:17. First period begins now until 10:05.
Oh, my friend's a miss.
Second period will go 10:08 to 10:56.
I'm so
Okay.
hungry.
We're good. We're good to go.
Third period will go 10:59 to 11:45,
No break.
which is the regular time for third period to end. 9:17 to 10:05, 10:08 to 10:56, 10:59 to 11:45. You will receive an email to that effect.
When's the break?
First period begins at this time.
Remember on math
Thank
day,
you.
there's no break.
Yes,
Again,
good.
Again, guys, there's never a break on math days. Okay. Now, let's think for a second. We talked about the other day in one of your homework problems, and you notice on one of them, you got roots that were imaginary. Do you remember that?
Yeah.
Okay, and that homework problem? The imaginary part, remember, it comes from this part right here. If what I boxed in blue is negative, it is imaginary, if you remember. If the radicand, which is the number under the radical, is negative, we have imaginary answers. That was in concept 1, if you think back, okay? Now, it's going to come into play. So this number under here is going to be our number that tells us what kind of roots we have. Okay, and we have a term for that. We call that in math, and say the word correctly when you say it, the discriminant. Not discriminate, but discriminant. Okay, I'll spell it for you. Okay, discriminant. Now, if you type that, it won't show up as it'll show up as a spelling error, by the way. It's a mathematical term that is not always recognized in all writing programs.
So discriminant actually goes with the b squared. Okay.
That is absolutely right. Okay? Now, another way that we show discriminant is by just a delta symbol. What does the delta symbol look like again? A triangle. Okay, another way you'll see this is with a delta. Delta is used in lots of different levels of math. Traditionally, it means change. Okay, it means change. Here it represents the discriminant. Now, I actually looked it up because I was a little bit curious the other day about where the word discriminant comes from. And the one thing I read that seems to make a lot of sense, it says it's derived from the late Latin word. Now, who takes Latin here? Who took Latin? Who wants to pronounce this so I don't screw this up?
I'm pronouncing.
Victoria.
No, I'm gonna
Victoria.
Don't give it to Victoria.
I'm not sure. Jason was Brian. In the back of the true Brian. Brian's back.
She didn't even get it either.
You're looking at that word.
Brian's back. Brian's back.
That's all the kids in my
Is it always on? Okay.
Yeah. He's got a wireless CD with him and an iPod. Brian's back. Brian's back. I told these kids in my class meeting, Brian's back. But not horn. Yeah. Thanks, Brian.
Okay. But here, this is how you spell the word.
Discriminating.
Okay, that's the word that is said to be derived from in Latin, and that word means to discern or to distinguish between. And that's what we're going to be doing today. It means, again, this word actually means to discern, which you'll see is actually in part of the word. Discern is right there. Okay, the English word to discern. And discern means to distinguish, to be able to tell the difference between things. And that's what we're doing today. We're going to look at different scenarios to be able to distinguish which outcome we will have based on b squared minus 4ac alone. We don't care about the rest of it. This is the only factor that will tell us or distinguish between a real root, an imaginary root, and we'll talk about another thing called the repeated root. Okay, we're going to have 3 different major types. There'll be a 4th subtype of one of the other ones. But today we're going to do 3 major different ones. And we'll go through simple examples to show that. Okay? Let's start with our first example. So the first one, we want to determine the zeros of the following function. Let's say j of d equals negative 2d squared minus 3d plus 4. Okay? Now, here's what we want to do. We want to be able to figure out the types of roots of this function. Let's go through this and actually use a quadratic formula the first time, and then see if we can make some sort of a conclusion at the end. So again, it's x equals, and I have a d, so I put d. X equals negative b, and I'm going to put the numbers right in. I'm not even going to write the formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, again, I'm simply plugging into the formula. Remember the formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. Now, at this point in time, it's just number crunching. I'll give you some of the numbers, what they look like, but you can do this yourself as you go through it. So clearly the beginning is going to be a positive 3 there, because it's a negative negative. Plus or minus, the whole denominator is going to be negative 4. That's the easy part, obviously, right away. The next part is not difficult, it's just that it's under a square root. Now, negative 3 squared, what does that become again?
9.
Positive 9, right? Or just 9, very good. Minus a minus becomes? Good, again, see the negative negative here? It's going to be a positive in the middle now. We're going to have 4 times 2 is 16, is 8. 8 times 4 is 32. What did I do in my head, guys? Quickly. Anybody notice what I did? I did 4 times 4. And then I was going to multiply by 2, but I said it the backwards. So you could do 4 times 4 is 16, times 2 is 32, or do 4 times 2 is 8, 8 times 4 is also 32. Either way, you're going to get a 32 on that side. So in the end, what's under the radical? 41. Okay? So on the side here, let's write down real quick in a parentheses, delta equals 41. Remember, we are looking at b squared minus 4ac. That's the important part today. And what does that represent, or where is that represented? Always whatever is under the radical. And that happens to be 41 for this example. Our answers we will get, if we split this up, will be negative 2.35 and 0.851. Okay? Again, right now we're just getting our roots, and we're going to make some conclusions once we see more evidence of different things. No, absolutely not. Your answer could have been left as 3 plus or minus root 41 all over negative 4. You can leave it as that, as the 2 roots. But for today, I'm doing this so we can see the effect of our roots, or the result of our roots as a result of the actual discriminant. So what do the roots come out to be based off this discriminant? That's what we're going to look at. So here's what I want to write. Hold on one sec, John. We have 2 roots here. Everybody see that? As we've discussed, 2 roots. They are both real. And take a look here. If you look at this part right here in the box, we'll notice that they're both irrational. How do I know that they're irrational? Think back to concept 1 between irrational and rational numbers.
There's no, you can multiply two numbers, the 2 of the same number to get 41.
Absolutely. Very good, sir. See root 41. Can you break that down at all?
Yes.
You cannot break it down any further. So here, we know that this is an irrational number. Irrational. So my roots here, my roots are real, okay? They are different from one another, so we'll call them distinct. Okay, they are both real, they are both different, so we call them distinct. And they happen to be irrational, based on what's in this box. Again, when we round our answers here, you can't really tell that they're irrational, because these look like decimals that terminate, but we are rounding our answer. So really, I should make this symbol, instead of an equals, what should I make it? Very good, approximation. Because again, I am rounding. My answers are irrational. But I'm not showing that here. You can't tell with the decimal. But you can tell with the rational. Okay, so they are real, distinct, irrational. Now, there's one other way we can describe them. You have to think back to when we rationalized binomial denominators. If you remember, side note, if you remember when we had something like 2 over 3 plus radical 7. What would we multiply by?
3 minus the radical 7.
3 minus radical 7 over 3 minus radical 7. And what do we call those? Anybody remember what we called those two values? We have 3 plus radical 7 and 3 minus radical 7. They had a name together.
Opposites.
They are opposite, but that's not the word we use, but that's a good way to think about it. The middle term is opposite, or the middle sign. I'll give you a hint. The first word was binomial.
Binomial.
Second word starts with a C.
Conjugate.
There it is. Binomial conjugate. Binomial conjugate. Remember that one? Okay, so here, these roots, if you look at them, if I were to break this up, see how it's a plus or minus? We would end up with, let me show you down here, the two roots. We would end up with 3 plus root 41 all over 4, a negative 4, and 3 minus root 41 all over negative 4. Well, take a look at this. These are binomial conjugates. Okay, because if I divide this 4 into both of these, I'm going to end up with a negative 3/4 and a negative here. I'm going to end up with a negative 3/4 and a positive here. Thus, they are binomial conjugates. So the last way we can describe the roots are as binomial conjugates. That one is not one that you see as much. If you see irrational, when roots are irrational, they come in pairs as binomial conjugates. And when the roots are irrational, you will see them appear as pairs, as one of the roots here and one of them here. And you guys know this already because of the quadratic formula. You know that you're going to have pairs here. Okay? They will always be. Now, again, that's when the delta value or the discriminant is a number like 41. And we'll talk about what kind of a number that is in a little. Let's go to our second one now. For the second problem, we have h of x equal to 2x squared plus 12x plus 18. Now, looking at this problem, let's start off the quadratic formula. Somebody want to step me through the numbers I'm going to use right now?
Negative 12
12
plus or minus
12 squared minus 4 times 2 times 18
over 2.
Over 2, that's right. 2 times 2. So here, look at your discriminant now. Let's figure out what this number turns out to be here. So in this case, we're going to have x equals, this is still negative 12. This is all over 4, plus or minus the square root. What's 12 squared, everybody? 144. What is 4 times 2 times 18?
144.
Oh, look at that. So what is our discriminant, guys?
Zero.
Be careful, it's just 0. It's imaginary when it's negative, okay? So our discriminant in this case is 0. Well, let's keep going. Let's keep looking at our answers now. Once we know that the discriminant is 0, we are able to figure out, actually, this part, what happens to it? It goes away, it drops off. So on the next line, I can write x equals negative 12 plus or minus 0 over 4. Well, if I plus 0, or if I add 0 to negative 12, what is it still? If I subtract 0, what is it still? So is it going to change, guys? So I'm going to end up with negative 12 over 4, which is what? So, but what does it look like? Shouldn't I get 2 answers?
Yeah, but
So what happened here?
There was no cheating.
What would it be? The same answer for both. Very good. Because again, it's x squared. So we must have 2 different solutions to the equation. But as Ashley just said, it's the same solution twice. Because we know that there are 2 answers, but the discriminant happens to be 0. So already for this one, we can say that the roots, okay, even though there's only 1, the roots are real. Okay, they are real. And last time we said they are distinct, meaning they're different. But now they're the same, aren't they? So we call this repeated. So the roots are real, repeated, and clearly this is not irrational anymore because it's a whole number. It's an integer, rather. I'm sorry, it's an integer here. An integer value is not irrational, but it is rational. Okay, it is real, It is repeated, and it happens to also be rational. Ashley. It will help you to use these words, absolutely, because you know why? Later on when we graph, it will be of good assistance to graph the stuff. Okay? So again, real, meaning not imaginary. Repeated, meaning it's the same root twice. Rational, meaning there's no square root we can't take the square root of. In this case, it happens to be an integer value. Thus, it is rational. Okay, third case. So again, so far we've got real, distinct. That was the first scenario. Then we just had real and repeated. What do you think the third one's going to be? Can't be real and imaginary or just imaginary. Okay, imaginary.
Imagination.
Thank you, John.
That's gonna be the recording. You're welcome.
I said thank you.
I know that's what I'm saying. You're welcome.
Should we play Imagine by John Lennon, Beatles? No.
Yeah. What you
Play,
imagine?
play.
Oh, that's not how it goes?
Imagine all the people.
I don't really listen to a lot of John Lennon. Or Beatles and John Lennon.
All right. All right, x equals, somebody else that didn't talk last time. Somebody new here, please. Step me through the quadratic formula for this one. Julia. Yeah, give me the numbers. Speak of it.
Negative.
Very good. Absolutely, very good. Now, with this problem here, let's take a look at our discriminants. Let's simplify.
There's two negatives.
Yeah, she's happy.
We end up with 36. Now, be careful, exactly. There are three negatives. These two negatives here, they cancel each other out. It becomes a positive 3 and a positive 5. But there's still a negative in the beginning. Remember, when you have three negatives multiplying, it is still negative. So here, 4 times 3 is 12. 12 times 5 is 60. So this is going to be 36 minus 60. Clearly, we're going to notice this time that our discriminant is, very good, negative, which makes our roots imaginary. Awesome. So here, when I do 36 minus 60, what do I get here?
Negative 24.
Very good, negative 24. Okay, and our two roots, let's go through this process still. Because this one is one we haven't done yet. Yes, sir?
Don't those cancel each other out? -6 and -6?
Yes, we're going to do that. That's what we're going to do next. So here, let's continue. X equals -6 plus or minus the square root of negative 24 all over negative 6. Well, instead of negative 24, what should I do?
24 times, the square root of 24 times.
No, negative square root.
I mean, 24 times negative.
Can I say it, please?
Yes, go.
The negative, square root of -6 times square root of 4.
Okay, we can do that very good. We can do 6 and 4 and break down the 4, absolutely. What else can we do? There's two methods that work. Take out a negative 1 and put an I on front. Remember, whenever it's a negative, make it a positive, put an I on front, then break it up, as Jason said, into 6 and 4. Okay, 6 and 4 here. So let's go through that process here. -6 plus or minus. I'm going to put an I out front. Okay, I'm going to make my remainder of what's left on the radical positive now. And I'm going to break it up into 6, and I'm going to break it up into 4. Now, Jason said square root of -6. This is the exact same thing, except I just took out the I all in one step. Okay, now, the square root of 4 is, everybody, 2. So this is going to become -6 plus or minus 2I root 6 all over -6. Again, this becomes a 2. I'm just simply bringing it in front right here, because these three terms are all multiplied. When all three things are multiplied, I can move them and mix them up all I want. Now, at this point in time, don't fall into the common mistake. You do want to simplify, but show me or tell me, where can I simplify here? The -6 and what else? What about this 6? How come? Good, it's on the inside. Remember we said, if something is on the inside and something is on the quote-unquote outside, we can't cancel them. So be careful right here, and as Vanessa just said, -6 over -6, 1 plus or minus. Now, be careful here. This is 2 over 6. What can I make it? 1/3. Very good. Or 2/6, I root 6. Okay, again, Now, theoretically, or in real, what I should really do is I should switch my plus or minus sign. I should make it minus or plus, because then I divide by a negative here. So when you divide by a negative, don't you normally switch the sign? But how can I feasibly switch this sign? The only way I can do it is by switching the order of them and putting minus or plus. But does that actually matter?
No.
No. But when you do math, it is good to know that, guys, because when you go on to proving stuff using calculus, you're going to need to remember that plus or minus, minus or plus actually does have a role. And we're going to talk about that at the very end of this year. When we get to, we're going to be looking at trig laws. So laws of double angles and half angles. Minus or plus and plus or minus actually have a big deal to do with it. Okay? So it is important that you understand what I'm saying here. So again, when I divided by this negative 6 into this plus or minus, it switched the sign. How do you switch a plus or minus? Make it minus or plus. But it doesn't affect our answer here. Okay? It does not affect our answer. Now, if we are to simplify this, we'll see that our answers will turn out to be 1, where are we? Plus 0.816i and 1 minus 0.816i. Now, these two values, again, the 0.816 is just the square root of 6 and then times by 1/3. The square root of 6 times by 1/3. These two values, what are they? How can I classify them? Give me some words to describe them with. Imaginary, that's one. Derek, another. Be careful. It looks like they're repeated, but look at the middle of the sign. What is it? So what did we call that in the last one? There was the binomial conjugate in the last one. Who remembers what this is called?
Imaginary to binomial.
I would personally agree with you guys. I would say the imaginary conjugates, right? There's a word, though, that we use in math, and I brought it up like once or twice in the first beginning of section 1, and it was called complex, okay? These are called complex, and complex simply means it's on the complex plane, which is the imaginary plane, or the imaginary world. So they are complex conjugates. Okay, imaginary, and they are complex conjugates. And notice we have two roots here, two roots. They are different. Okay? They are different. They are not repeated. That's the hard part there. They are not repeated. Okay, so we have gone through 3 scenarios now. Based on those 3 scenarios, what we want to do is make some conclusions. Okay, and I'm going to summarize the numbers that we looked at, and I'm going to have you guys make the conclusions. So, when the discriminant was 41 in the first case, in the second case, the discriminant was 0, and in the third case, it was negative 24. In the first case, the discriminant was positive. Do we see that? Okay. So what can we say about this? What kind of conclusion can I make? Look at your description when we did the first problem. How did you describe your answer?
Oh, so when it's imaginary.
Well, we're on positive right now.
Oh, sorry, when it's positive, then it's around the
Real? Okay, so when the discriminant is positive, okay, when the discriminant is positive, so here put positive in the parentheses or next to it. When a discriminant is positive, John, what kind of roots were they?
real.
Good, what else?
And repeated and rational.
Not repeated.
Oh, sorry.
You're on the you go to the previous one.
Distinct and rational. Yeah. And
Real, distinct, and what else?
irrational.
We had irrational here. Oh, plug's plugging in, hold on. Irrational. Okay? If they're positive. Now, we're going to talk in a second about if they're positive, but a certain type of number is here, it will be rational. We'll talk about that in a minute. Yes, let's keep going. I'm going to see who else can see that. The 0 here. What kind of roots did it have when the discriminant was 0, Derek? Repeated. What else about them? They're also real. Very good. Okay, they were real, repeated, and they were rational. Thank you. Okay, they were real, repeated, and rational. Now, personally, I would probably switch the order of these two in your notes. I would write real first so that I can see that I'm listing the realness or imaginary in the beginning. Then I'm listing whether they're distinct or repeated. Then I'm listing whether they're irrational or rational. So I'm categorizing by columns now. So if you switch these two, we can't switch them both at the same time. I would write it as real and then repeated. Okay, again, why am I doing this? So I can categorize. So I'm using this category and this category as things. So I know that I'm talking about the realness in the first column. I'm talking about whether it's the same or different in the second. And I'm talking about the types of roots at the end. Irrational, rational, and the last one will be complex conjugates. For the negative 24, what do I put here, everybody?
Imaginary.
Imaginary, good. Okay. In the middle, we don't have to put anything, but they are distinct. We could put distinct here, because they are definitely different. And then the last thing we did to describe them was complex conjugates. Now, there is one thing you should know. You can have complex conjugates that have irrational parts also. And if you look at our last example, take a look at our answer at the end. Wasn't this our real answer right here until we approximated the two numbers here? So this answer happens to be imaginary, and the imaginary part also happens to be irrational. Do we see that, the radical 6 here? You can't break down radical 6. So this one happens to also be irrational and imaginary at the same time. Okay? Now, those are the first three categories. So again, if it's positive, if it's 0, or if it's negative. Now, there is one other way to describe this. Okay? And it has to do with it being positive. But in this case, if I knew that the discriminant was positive, and I wanted to get, instead of irrational roots, I wanted to get rational roots. Again, I want rational roots instead of irrational, but this is still going to be positive. What can I say about the discriminant? What must it be? Let's look back if we need to. Go back to our first example. Here, we had the square root of 41 under here, right? And we couldn't take the square root of it. Thus, it was irrational. If I wanted my roots to be rational, what kind of a number must this be under the square root? I know you got it. Hold on, let's run this.
Does it really have to be like for example, 9 or something like that?
And what is that called? What kind of number is that?
No, it's not
9, 16, 25.
Prime.
prime. No, not prime.
Even.
Not square root, but
Square.
perfect square. Perfect square, okay? So let's go back. You had the right idea there. That's good. Okay, so if there's one subcategory of this category, if it is positive and it's a perfect square, okay, it is still real, they are still distinct, but now instead of being irrational, their roots are rational. Now, the easiest way to think about it is this. Whenever you have this last category, you'll have either, you could use factoring or AC method to get your answers. Because remember, think about AC method, think about factoring. Aren't those answers rational numbers? It's always like x equals 2, or x equals 3/5, or x equals some fraction or decimal or whole number. So here, when you have this fourth category, you probably won't ever really see it that often because good chances are that you're going to actually factor it instead. So if you factor it, this is the kind of category you're in here. If you cannot use AC method or you cannot factor, you are going to be in this category if you're going to have real distinct roots. If you have a, let's say, here's a simple way of saying this one. If you have a quadratic that looks like this, and you are to factor this, how do I factor that quadratic? What is it?
3 times 3.
3 and 3, right? So what are these kind of roots going to be, guys?
Negatives.
And what else?
Maybe the same.
The same. So what kind of roots are those? What do we call those when they're the same?
Oh,
Repeated. Very good, Trayvon. So whenever you have a quadratic that has a number here, and if you take half of that number, and you take the square root of this number, again, take the square root of this number, you get a 3. Take half of this number, you get a 3. If those two things happen to be the same here, then what are we going to have here? We're going to have a discriminant of 0, where the roots are real and repeated. And you'll pick up on this more and more. Even if the middle number was negative. If this was a negative 6 instead, what do I make all these values? I just switch all the signs. Oops. Yes.
You have the pen up. That's all.
No, it's been doing this lately. It has to like load sometimes. It's so weird.
Okay.
So again, we'll have -3 and -3 instead. But still, take half of this number. It's -3. Take the square root of 9. It's 3 or -3. Remember, the square root is 3 or -3. So we have 4 cases here. Okay? We have 4 different categories that we're going to look at. Let's simply look at a way to do this by looking at the discriminant alone. Okay? So let's go through an example. We're going to go through like 1 or 2 of them. If you're given the function, let's say g of x equals 2x squared plus 5x minus 4. And the problem just says the following. What kind of roots does this function have? Determine the types of roots of this function. Determine the types of roots, or the type of roots of this function. I don't need the whole quadratic equation. If I can determine delta, or b squared minus 4ac, I can then look at my categories and figure out which one it's in. So what is delta in this case? Who can step me through this? What's b squared?
25.
Minus?
2. -4.
Okay. 25 plus 32.
32.
It's a plus, guys. This is a plus.
Yeah.
Right? Negative, negative makes it a positive. Now, if my discriminant or my delta value is 57, which category do I fall into?
The first one.
The first one. Because it's positive, right? And it's not a perfect square. If it were a perfect square, we'd be in that 4th category. So since it's positive, we go back at our last example and take a look. Well, we are in this top category right here. We know that we are in this value right here. It is a positive 57. Thus our roots are real, distinct, and irrational. What are my perfect squares? 9, 16, 20. It's all right. 9, 16, 25, 36, 49. Just do all your squares, okay? 1 squared, 2 squared, 3 squared. Now, what square is near this, though? 64, and what's the other one that's kind of close by also? 49, right? So we can tell already that the square of this number will be somewhere between 7 and 8. You guys see how we're doing that? 7 squared is 49, 8 squared is 64. So this square root of this number will be somewhere in between. But it doesn't matter, because the problem just said, find out the types of roots. Find out the types of roots. Now, before we go on to the next few examples, I want to show you guys how to use your calculator to write a program that does this for you already. I'm also going to give you a handout to take home with you, but I'm going to step you through the program. If you get lost at any point in time, Mr. Carter's going to be walking around asking for assistance. I'm going to give him a copy of the program written right now, so he has it. Where is my So take out your TI 84, 83. If you don't have one, you have to look on with somebody. You need to make sure you understand what's going on here. So it's just a step by step. I'm going to go through it all. Now, if anybody here is interested at all in computer science or computer coding or computer engineering or any engineering, this is a great preview of the stuff that you might do. It's a very simple code we're going to write, but it's pretty amazing the way it works. Now, I've already written the code in here. I'm going to write a new one, though. So you'll see under programs, I already wrote a program for the quadratic formula. And you know what? Before even showing you the program, let me show you a quick example of what it'll look like.
But you showed us this last year.
It's possible I showed you one last year with the law of cosines. That's the first one, Jason, right there. That's what we did last year.
Yeah, cosine.
So if I wrote the formula, and what it does is this. It tells you, it's got to be in standard form. So it gives you the form in the beginning. Then it says, tell me A, tell me B, tell me C. In the problem we just did, our values for A was 2, B was 5, and C was negative. And notice I pressed the negative down here, negative 4. When I hit enter, it's just going to spit out the roots. I hit enter, and there are my 2 roots right there. Okay? What has happened, though? There's a lot going on behind the scenes. We can't just assume that this is right. We got to know the way the program is written to make sure it is. Now, first of all, if you remember, we said the roots were real. Clearly, there's no I here. They're real. They were distinct. They are different. And they were irrational. We can't really tell the irrationality of this one, but we can see that there is no number pattern to the decimal as of right now. So we can at least say that there's a good chance they're irrational. But we can't always tell because we don't see the square root. Now, to write the code, go to your programs. Everybody go to program, and I'm going to give you a handout that has all of this at the end. I want you to go through it with me. We want to start a new program we're going to write in our calculator. So, we go over to new. So go over 2 spots, hit enter. Now, we want to know what the name of the program is. It doesn't matter. Call it whatever you want. I called it quad because it's the quadratic formula. Call it QF. It doesn't matter. Now notice, this is flashing with an A. What does that mean?
The letters.
Alpha what? What was that called?
Mine's flashing with a C.
Good. It tells you that you can use letters right now. It's flashing. It's on alpha lock, which means you're always going to type letters. So see all these letters in green on my calculator here? You guys have them in another color based on which one you have. You'll see all these letters here. Type in whatever you want to call it. I'm going to call it Q, and then I'm going to call it F. For quadratic, call it whatever you want. It's up to you. I'm calling it QF for quadratic formula. Now, go to programs. If you get lost, please raise your hand. Don't fall behind. Go to programs, go over to new, hit enter. Then type in the name you want to call it. I'm calling it QF for quadratic formula. Now, when I begin this program, I want to think to myself, I want to have some sort of a display in the beginning of what I'm doing. And that was the x squared part at the beginning. So here's how I bring up a lot of my commands. I press second, and then I go down to this thing called catalog. Go to catalog. It'll bring up just a list of things. Now, I want the calculator to display the general form. So I'm going to go to the D. So press alpha, and then press the D. And just press the D. Come on. Alpha, D, there it is. Press alpha, and then press the D symbol. Is it on alpha lock already? If it's on alpha lock already, just press the D. And it'll jump to all the D commands. I want the calculator to display something. So I'm going to go down until I see display. Now there are 2 displays. I don't want to display a graph or a table. I want to just display some letters. So I hit enter on display. Now, I want to display something that will not have any effect on my program. So I put quotes around it. And quotes give it the name. So here, to find quotes, look on your calculator. Do you see quotes anywhere? I'm pretty sure I see them somewhere. See the plus and under the green here? Look at the plus sign, and above it to the right, you'll see little quotes. So press alpha, and then press the plus sign. Again, alpha always brings up any sort of text. So quotations, letters, stuff like that. So again, I pressed alpha, then I pressed the plus sign to bring up the quotes here. Now, at this point in time, I want to display the equation. I want to say ax squared plus bx plus c equals 0. So, press alpha, a. Now, to do x, you can use the x here, or you can use the x letter. I'm going to use the x here. It doesn't matter because it's in quotes. It's just reading as text anyway. So, ax squared, the square symbol's over here, plus, now I want to b, alpha b, x. I know it's tough, keep with me. Alpha b, then press the x, plus c, alpha c, and then I want to close my quotes. Now, I'm sorry, I want to say equals 0. The equal sign is hidden on this calculator because it's a logic operator. A logic operator is this. Remember last year we had the if-then statements in geometry? If this, then this? That's a logic operator. So what we're going to do is say, whenever you use the equal sign, it's used for things like, if the value of this equals this, then tell me this answer. That's why it's called a logic operator. But here we're using it as text. The location is under second, and then hit test, where you see math. So second test, and you'll see the tests here. Okay, these are all logic operators. Greater than, less than, greater than, equal to, less than, equal to, or not equal to. Just hit enter, and put the number 0, and then press second, and then press the quotation to close your quotes. All that has done for me as of right now.
Alpha.
Sorry, thank you.
Oh, it takes a lot, Mr.
Just all you got to do is this, guys. Go back on the letter and press delete to clear it. Don't press clear. Don't press clear.
I'm not even there. Yeah, thanks.
Just go back.
John, what is going on?
So how did you push second in?
I don't know. What did you do?
I didn't do anything. Those are all the stuff that you input. That's what it shows.
I didn't put that. It was in another place. You're the math wizard. You have to fix it.
I don't have it no more.
Jason, give it back.
Ooh, she
You think it's
wanted
all John,
that.
right?
Yes,
You
John.
put it on the home page, John? It's on the home, on the home. You gotta go to your program. It's nice.
Jason.
I give up.
What are you doing?
Jason.
Take your program, start getting caught up. Alright, guys, we got a lot to do still. Focus. Sorry.
Delete all of this?
Figure it out. Get caught up. I can't stop you now, John. You made a mistake there. I apologize. Now, at this point in time, we are done with this line of code. Hit enter. Put the next line of code in. So this is how you calculate it. Display that equation in the beginning. Now, next, just go to the end of it and hit enter. Again, go to the end, hit enter. Now, we want the calculator next to ask us, what is A, what is B, what is C? On a calculator or programming, it's called prompting the user. When you prompt someone, it's like me saying, 2 plus 3 is, and you guys will say 5. I'm prompting you, okay? So here, we need to prompt the user to say, what is A? So we go, second, catalog. Now we want to go to prompt. It's already, again, you press second, and then we press the catalog button down here, same as last time.
I'm still back at the 0.
Hit enter, go to the next line.
Okay.
Second catalog. Now, you want to go prompt. So look for the letter, it's already on alpha lock, so it's under alphabet. So press the P. The P is located above the number 8. So press the number 8 now. It'll go down to the P letters. We want to go down with our arrow keys to prompt. There's no shortcut besides going down at this point. So go down to prompt. If I can get there ever. There it is. Okay? We want to prompt. We want to ask the user the values of A, B, and C. We want all 3 of those values. So to do so, we have to ask the user to prompt them. So hit enter. Now, I want to prompt A. How do I input A, guys? Alpha A. So press alpha, then the math button below it. What else do I want to prompt? But what else do I want to prompt? B, and what else? C. I don't even need an equal sign. When you prompt, the prompt automatically puts an equal sign. So here, all I need is a comma. Here's my comma, right next to the parentheses. Okay, I want to prompt A, B, and C. Alpha, whoops, alpha B, comma, alpha C. Enter. Now that line alone is what brings up A, B, and C. Okay, the rest of what we're about to do is what gives you the answer. This is where it gets a little bit trickier. Okay? Now, we want to define a variable. Okay? We want to define a variable that says my D value is defined as my discriminant. So what was my discriminant defined as before? What letters did we use? What was under the radical?
B.
Not negative B. B squared
Minus 4A.
minus 4AC. We want to give that a name, a discriminant. So here's what I'm going to do now. I'm going to press alpha B squared minus 4AC. Again, B squared minus 4AC. Now, I want to store that in the calculator as another term. I want to think about that discriminant. Here's how I store stuff. See STO? Press store. It'll bring an arrow. It means let's define another variable D, and we're going to call it D in a second, as B squared minus 4AC. So press alpha, then press the D, then press enter. And what this does is this. Once you input A, B, and C, it stores the quantity B squared minus 4AC into a variable D. And I'm doing this so that my next line of code is a lot easier to write. I don't want to write the whole quadratic formula out. X equals negative B, the whole thing. So instead of having to write B squared minus 4AC, I could just write D now. Remember before how we defined B squared minus 4AC as delta? Okay? Now, when I write my code in the next line, I don't care about B squared minus 4AC. I'm just going to call it D now. Because this is B squared minus 4AC. Okay? So here. Say again?
Your batteries are almost dead.
Thank you. I need my battery charged.
Oh man, I didn't know we actually.
That would have died. We would have lost it. We wouldn't have recorded anything. We did that.
Thank you, Tony.
Oh, it's dead.
And that's your loss, guys. You wouldn't have a video to watch. You know?
It's called YouTube.
I know.
He said it's called YouTube.
Good. You should be looking at videos. I'm glad. Now, the next line.
It's an example.
Remember, the next line of code just showed me the 2 roots, right? It gave me the 2 answers. So again, I want to display the answers. So I go back. I go second, catalog. Press the D to go down to display. Press the down arrow until I get to display. DISP, hit enter. What do I want to display? I want to display the actual answer. Well, the answer, as we know, is x equals, this is the answer, negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, what's b squared minus 4ac defined as? D, right? So I can simply put a d under here now.
D divided by 2.
Okay? So I write negative b plus or minus the square root of d all over 2a. This makes it easier. It's less coding. So since I save time here, or I'm sorry, I use more time to write this line, I'm saving more time in the next two lines. And this is an operation that you use in computer science. You define a function and then recall that function later on. So now I'm going to recall the d, but I need to write it so that it looks like this. Can somebody tell me what this should look like? Jason.
Negative alpha at.
Okay, before you go any further, let me just say one thing. This whole thing is the numerator, right? So what do I need around it? So after that, then continue. So parentheses. Go ahead, Jay.
Somebody else can go.
Okay.
Negative b.
Negative, so then I press alpha and then the apps button again. Remember, negative is down here. This is minus over here. This is the negative down here. Okay? So negative b, good. Now I want plus or minus, but there's no option for that. I can't write the word or, I can't do a plus and a minus, it'll give me an error.
Can't you just do the plus and then like the division sign and the minus?
Doesn't work. Doesn't work. That's a good try, though. I understand that. Jason's saying, can't we just do plus slash minus? Here's what we have to do here. There's no plus or minus. So we have to write this line twice. So we're writing it once with a plus, and the next time with a minus. So plus the square root. Where's the square root, guys?
Second
Second x squared. Good. The square root of d. So now press alpha d. I don't want to write b squared minus 4ac. Why two parentheses?
First it close to square root, and second it close to numerator.
Good. So we close the numerator all over 2 alpha a. All over 2a.
Dang, I gotta learn all of this
Okay?
again.
D is b squared minus 4ac. Now, you have to write the next line still. Listen carefully. You have to write the next line. Once you've done that, there's one more line of code. The code is right here, so you can continue writing it. And the last 4 lines are the same. It just says delete variable A, delete variable B, delete variable C, delete variable D. Once you finish this code, I'm going to give it to you on the way out. Make sure you practice it and try it out. You can save, the program will automatically save. And when you want to use it, you don't have to go over to edit. Just go over to the first column. When you want to use the program, just press program and then go down to the name and just hit execute, hit enter. And then hit enter again, it'll bring up the program.
So how do you execute?
Listen, over break, you can save progress just by pressing second quit. It will automatically save the progress. Over break, here's the code. Read through the rest. Here's your homework. Okay? Make sure you get to all your homework. There's the lot. That's 10 problems. You got all break to do it.
Clear.
Okay? On the way out, grab one of these, please. One of these.
Everybody to exit out, push clear.
No!
No, I always think it's my phone.
Do you have a quiz?
Yeah.
We do?
Yeah.
Okay, who needs papers over here?
Those shortcut stuff. Oh, wait, I'm missing all of shit.
Go.
I don't remember if you do that.
Guys, have a great break. Be safe.
I'm gonna eat so much that I'm okay. Wait, so how does that whole thing
All steps, number 7 is on that. Show me.
I'm not wearing my dress shoes.
No, it's not.
They are
Rip off the bottom? Huh? We're gonna do that bottom. So did you have to use the Mariah Carey?
Yeah, I went.
You went?
I went. My sweater and my boots.